Hey everyone, welcome to CIS255 database environment. We're going to talk about MDM, Modern Device Management textbook. We're going to go over the Chapter 1 PowerPoints. Okay, so I'm going to try to divide these lectures up where the lectures on theory, the PowerPoint lectures, are separate from any hands-on labs type thing that I'm going to have you do. That way it's easier, in my opinion, for you to find. If you're looking for the demo video on how to connect to the OM database, that'll be in a separate video. So anyway, so let's get started. Theoretically, we're going to cover chapters 1 through 6 in the MDM book, and if time permits, 7, 9, 10, and 11. In the Muroc texts, we're going to cover chapters 1 through 5, and if time permits, 7 through 10. If we have to cut back on lecture material, I'm going to cut out the MDM device, or the MDM textbook. It's a lot of ER diagrams, it's a lot of dry theory about databases and blah, blah, blah. The Muroc textbook is more, here's how to connect to a database. Here's how to pull information from one table. Here's how to pull information from 2 or more tables. So the theory here lends itself more towards the hands-on stuff. Okay. So like I said, this is the first time I'm teaching this online, so this is going to be a bit of trial and error for me. I'm going to try to teach it in the same order I taught on campus classes. The difference here will be I won't have access to real-time feedback and questions from you, so we'll have to play it by ear. Please do let me know if you have questions, if you run into any issues, whether it's connecting to the labs, ambiguity with the slides, etc. All right, so let's get through this first slide deck. It's only 37 slides. I do like to tell folks how long the slide decks are so you can kind of prepare yourself for, is this going to take a long time or isn't it? Now, I am the kind of person who can take an hour and a half to watch 60 minutes, but I'll try to not be as verbose, and we'll see how that goes. Okay. So, Chapter 1 of the textbook, as is the case with all textbooks. Here's an introduction to the textbook. Here's an introduction to the course. Here's a lot of introductory concepts type things, right? This class will be no different. Okay. So these are the 11 objectives, Chapter 1. Now, I had a whole list of terms and definitions that I wanted to throw your way. And then I thought, how would I feel if I were in your shoes? And I just was presented with this long list of things to memorize. And then I was, okay, maybe I'll cut back on this. So, yes, the slide deck was designed by Pearson, the publishers of one of the 2 textbooks that I'm using in this course. But that doesn't mean that I'm unable to modify these decks. So this is slide 4 in deck 1 of the MDM text. Just in case on a quiz or on a test, you would get asked to, hey, define database, define data. What I would ask you to keep in mind, whether you memorize or you don't, right? That's kind of really up to you and your study habits. What's the difference between data and information, right? And the answer can be as long as a day, right? A whole 24-hour long answer. But really, data is a lot of the stuff that you're collecting, or maybe all the stuff you're collecting. In and of itself, data isn't very useful. Once you process the data and you turn it into information, that's where it becomes useful, right? Because information is data that has been processed. We're hoping that processed correctly, information can help us make more intelligent business decisions. Now, depending on your work history, you may currently work or have worked in situations where the answer could be given to your bosses on a silver platter, and they're still not knowledgeable enough to make good decisions. Hey, I can regale you with stories for days of dumb managers I've worked with and dumb decisions I've made, right, based on faulty data. But and lastly, right, metadata is data that describes the data, right? As confusing as that definition might be, it talks about the properties of the data you're looking at. So it could be, what are the field names we're looking at, right? Employee name, for example, right? So you might have a table of employee information, right? Names, dates of hire, number of dependents, and things like that. The metadata refers to the information about the employee data in that table, right? And that can include like column names and data types and things like that. So here you're looking at a report. It includes several different types of data entities. Now, we're going to learn about the terms entities and attributes a little bit later, right? So here in this report, we have a courses section. We have courses listed and the sections of these courses. We also have students that are enrolled in this particular section. So what we've done is we've taken raw data, student information, the student ID, the student's major and their current GPA, and we've turned it, into useful information. Now, how this gets done, okay, this report can be based on a query that we write, such as select all students whose course equals Mgt 500. Okay, so we're selecting field names from a table of raw student data, but only if those students have registered for this course. So rather than seeing 6,000 students, we're only seeing 6. Okay, this report is formatted in such a way that it's easy to read on the screen. If you work in an environment where this needs to be printed out, this would be easy to read on paper. And it looks to me, at first blush, that the data in this report is sorted alphabetically by last name. That may not always be the case, but it makes the most sense to me in this context. We could, if we wanted to, design the query in such a way that we're grouping first by majors, then sorting by last name. Okay, this report can be as, let's say, complex or as simple as you want it to be. These columns can be in any order you want them to be. Although, because not every professor has every student ID memorized, does it make sense to sort first by ID? No, not really. I have no idea, as I'm sitting here at my desk, what your major is. Does it make sense for me to sort this data in order by major? No, not really. But I do have a roster of all your names, right? And so I can compare my roster in Bannerweb to the folks who send me emails, the folks who, come to class if this were an on-campus class, etc. Now, we're not going to get this far into designing reports and other output for data, but we can use things like Power BI and Microsoft Access to an extent, right, if we're using very simple databases, to draw pie charts, line charts, etc. If you've worked with Excel, you know how easy it is to take existing data and convert it into a pie chart or a line chart here. It's a little more complex. I don't know if any of you have experience designing dashboards, etc. in Power BI. I'm just now starting to learn the basics of Power BI. But I have extensive experience with databases and with Excel. So I would think that given this fictitious student data, It might take me a couple of hours to figure out how to do this, but easy enough, right, to print these things out. So I described metadata a couple of minutes ago as data that describes your data, right? And as confusing as that definition might be, here it is. What's the metadata for my student database? Well, I've got field names. I might have table names in here. We'll talk about tables later. What data type is the course entity? An entity is a field name. Well, alphanumeric, meaning it can include text and numbers. Okay. Also special characters. How long, right? What is the column width? Does L-Tri-C have any courses where the course field is 30 characters? No, I don't really think so, right? It's CIS-255 or CIS space 255 or CIS no space 255. All right, so to the best of my knowledge, L-Tri-C's maximum course length will be 7 characters, right? If it's CIS and either hyphen or space, followed by the 3-digit code. Okay. The only reason I'm bringing that up now is if I've got fields whose widths will never be greater than X number of characters, maybe you don't make this field width 7, just in case in the future L-Tri-C decides to go to 8, 9, maybe 10, right? So maybe instead of CIS, right, it'll be comp sci 255 or something like that, right? So maybe when you're designing your table, you don't want to statically say, because then you're locking yourself in. Now, the reason this is important, one of the many reasons, if I decide to use 30 bytes as the width of this field, the database is reserving 30 bytes of memory to store information in that field. It can potentially reserve 30 bytes of disk space, even though currently 23 of those bytes will be unused. Okay, 23 whole bytes of memory, wow. 23 whole bytes of disk space being wasted, sure. But what if over the course of L-Tri-C's 50-year history, we have 1 million students? Now, I don't know what the total historical student population has been, but let's say 1 million. Wow, that's okay. I'm wasting 23 bytes per student times 1 million. Wow, okay, that's still only 23 megabytes. Okay, so you might laugh that off, right? If you're a comp sci major, you might think a whole 23 megabytes, right? Who's going to sweat that? I've talked to SQL DBAs at my current position with Microsoft. During the hiring process, right, if I was part of the technical interview team or whatever, one of the questions that would come up is, what's the largest database you've ever worked on? Some of them have worked with databases in the tens of terabytes in size range, like 10 to 12 terabytes of data. Imagine having to work with that much data, back up that much data, pull queries from that much data. In a case like that, where we're working with very large databases, 23 bytes per record, slowly, but eventually will add up to a whole lot of wasted space. So, long story short, what should I do here? Well, the answer to the question is, it depends. But maybe, if you feel confident, currently then we're only wasting 3 bytes per student. Okay, so metadata. the whole purpose of this slide, and I went off on my tangent there. Field names, data types, field lengths, metadata min or max, not normally a field I'm going to include in my database, but in the electronic planning or paper, right, whiteboarding, and then we're writing it out, you know, in a Word document, in a Visio diagram, this information may become relevant. Where this information becomes relevant in the database design is our sections at L-C are things like 1. So CIS255 hyphen N1. Well, the minimum section number in the database will be 1. The maximum for us, I don't think I've ever seen a section number higher than 2 digits, but again, maybe you leave it at 9 just in case. GPAs, I've talked to some high school students, right? My friend and I, we run a lot of wrestling tournaments for junior high and high school up here in Schuylkill County and the surrounding areas. So I get to talk to a lot of high school coaches and high school wrestlers, you know, and depending on how long the day is, sometimes we're just BSing about random stuff. I've come to find that some high schools now, sorry for my penmanship, I'm a lefty, and I'm using my right hand on the mouse. Some high schools now, instead of a 4.0 GPA scale, they go up to 5.0, right? Because I had one student, he was talking about the different colleges he applied for, and right, he had to fill out this paperwork, and he put in that his GPA was like, it was like 4.9. And I looked at him funny, like, wait, what? And so he started laughing because he's like, you know, I'm an old guy, so, you know, times change, and, you know, because I'm old, I don't really change with them. He's like, yeah, my school ranks us on a 0 to 5 point scale. Oh, okay. So that's what it is. The chapter talks about old school file processing prior to the invention. Excuse me. Sorry about that. Prior to the invention of databases. Long story short, or long story hopefully not as long. The old school way of file processing involved paper, and when file processing systems were first invented on the computer, your company might have 2 to 10 different systems for human resources. Some companies, human resources was separated from payroll. You might have another system if you were a manufacturer of goods. You might have another system for if we were all employees, right? How many widgets did I make this time last year so we can compare my performance this time this year, kind of thing. Part of the problem is those different file systems, they didn't talk to each other. And so this is where databases came in. Okay. Other issues, if an employee was either quit or terminated, and I removed them from the human resources file processing system, but I didn't remove them from the production or the payroll, right? If human resources and payroll were 2 separate systems, I might have duplication of data. I might have data where my last name is spelled Kelley. Somebody may put me in spelling my name Kelley. Well, will the bank cash my paycheck if my name is spelled incorrectly? Maybe they will, maybe they won't. Okay? So I've got these disparate systems. I've got this duplicated data. I've got this data that is not complete. As a new hire, maybe I get put in 2 of the 3 systems, but somebody forgets to put me in a 3rd system, etc. Okay, so back in the late 1600s, it seems, we started getting off these file systems, and that includes Microsoft Excel as well. Okay, and we started getting into either a 2-tier or 3-tier system. Okay, now the textbook talks about this fictitious company called Pine Valley Furniture. And yes, I know we're close to the beginning of the semester. I should have made this decision already, but I'm still on the fence about whether or not I want to give you Pine Valley Furniture as a project. Now, the Pine Valley Furniture Company, again, it's a fictitious company. They make legs for tables and chairs, right? They make sofas and love seats and rocking chairs and things like that. We can download a whole fictitious database related to Pine Valley Furniture rather than creating this database from scratch. So if we're going to do this project, that's what I'll end up doing, is downloading the actual pre-built database, and then we can just run things like joins and queries from the existing data. I'm teaching you how to create databases from scratch. That's a bit beyond the scope of what this class is meant to be. Okay, but anyway, this is a graphical representation of what I said on the previous slide, right? In this case, we've got 3 separate systems. We are entering information about, let's say, program or project A. So let's say project A is a customer has a restaurant and they order 30 custom-made tables for their restaurant. Well, we at Pine Valley Furniture have to ask the question, okay, what stuff do I need to make those tables? What kind of wood do I need and how much? Are the legs pre-fabricated, or do they send us these wooden blocks and we have to fabricate them? Right? What am I ordering? Right? How much wood glue? How many nails, screws? You know, are they pre-finished or must we varnish them? Blah blah blah. We're entering that information here. Someone else, most likely, how many items did we order? And they have to ensure that 100% of the stuff we ordered gets added so we can bill the customer correctly. What are the odds if I have one person, oh, I don't know what happened there, one person adding information to this database and a separate person adding the same data, theoretically, to this database? What are the odds that there's going to be some missing or duplicate data? It's almost 100%. What if our employees are paid based on the number of projects they work on? So we have to have a separate third person in payroll say, okay, Mike and little Johnny and etc. worked on project A. Let's make sure that they get paid for working on project A. Okay, so we've got all these repositories. These cylinders are the paper equivalent of storage. Okay, in this case, they're meant to represent the files on the computer that store the data, right, as opposed to the data itself. So I've got 3, 5, 6 total repositories where I've got 1, 2, 3 different departments, potentially 3 different people entering the same data 1, 2, 3 times. What if we're halfway through project A and the customer says instead of 30 tables, we need 20? Or they cancel the project. Okay, the orders department says, well, it's easy enough to deduct 10 tables. Instead of 30, we only need 20. Would you bet your paycheck that the accounting department's going to get wind? We're invoicing them for 20 now and not 30? I wouldn't. If, because we need fewer tables, little Johnny gets to continue working on project A, but I am taken off of project A to work on something else, Would you bet your paycheck that the payroll department remembers to remove me from this project? Again, I wouldn't do that. So the long-winded answer, I know I said long story short, and I apologize. We're trying to get away from this. This is a terrible idea for all the reasons you can envision, and probably many reasons you can't envision. Okay? We're trying to store all the information about the widgets or the dining room tables we're making, the employees, etc. Yes, it's okay to store them in separate repositories. I wouldn't want my payroll database to be mixed up with my accounting and orders databases. Right, that's perfectly understandable. But what we are trying to do is eliminate, where we can, duplication of effort. Because 100% of the time, that's going to lead to incorrect data, inefficient storage, and someone either getting paid too much or not enough, our accounting department billing for not enough or too much, and all of those things are bad. Okay, so we'll talk about data models in the MDM book, chapters 2 and 3. Specifically, we're going to talk about something called an ER diagram, an emergency room diagram. No, I'm just kidding. It's entity relationship. Hey, it's actually written with an E and a hyphen there, but I always forget the hyphen. Who cares? Hey, I'm not going to test you on something stupid like that. An entity relationship diagram. We'll spend a little bit of time working on an ER diagram, and I have a screenshot in a subsequent slide. The ER diagrams are paper copies, right, or electronic copies, where we're using Lucid Chart or Visio or something else to design logically the way that we want our physical database to look. Okay, we're going to talk about data models, but we're not going to spend a lot of time there. Data modeling is something done by very experienced database engineers, and this class is geared more towards entry-level DBAs or database administrators. Okay, so you might, if this is what you plan on doing for a living, you might be looking at someone else's designs for data models, but until you're pretty far along in your career, you won't be making them yourself. Okay, so this talk about an ER diagram. What is the E? What is the R? Okay, entities are nouns. They're the data that you put into your student database. An entity would be if we had a professor's database at Ch01. I'll have a record, right? Mike Kelly will have a record in that database. Well, the Mike Kelly record is an entity. Okay, it has my name, my L number, my date of hire, etc. Okay, the R in the ER diagram refers to relationships. How do the entities in the professor's table or the student's table relate to the other tables? So the Ch01 database might have a professor's table and a student's table and, let's say, a courses table. Which professors teach which courses? That's the basis of an ER diagram. How do the entities in the professor table relate? One professor, me for example, this spring of 23 semester, I'm teaching 6 different classes. One professor, me, teaching many different courses. One to many is the relationship type. Okay. Each course individually can only be taught by one professor. A one-to-one relationship. How many students per course? One student can take multiple courses, right? If you're a full-time student, I think it's 12 credits, right? This class is 3.5 credits. So you'd have to take a total of 4 different classes, one to many. But you're in CIS255, whatever section number this is. How many different times are you, the individual student, going to register for CIS255? One course taken by one student, 1-to-1. Okay, we're going to delve a lot more deeply into that. Okay, because we could say, if we look at the student table as a whole, many students are taking many courses. That might be considered many-to-many. Okay, I say might be because there may be students in this table that are not taking any courses this year, so there's no relationship. But again, more details will follow. I have to keep an eye on my time here. So can I get through this slide deck in the time I have left? Here is a very basic look at a very basic ER diagram. This is called crow's foot. And again, I apologize for my penmanship. I'm trying to draw freehand with the mouse. Okay, it's crow's, that's supposed to be an apostrophe, right? Crow's foot. This side of the relationship connector indicates 1. This side of the relationship connector indicates many. So I would write this out 1, the letter M for many. One customer places many orders. Many orders can be placed by one customer. Okay, so yes, you could say, if I look at the order table as a whole, many orders can be placed by many customers, but generally speaking, we're not going to read it that way. Okay, we're going to read it by, in this specific case, we might be looking at just individual customers and the orders they've placed. Okay, so in that result set that we get from running that query, we might have one line item per customer. How many different orders did they place? Depending on how we formulate the query, we might have multiple line items. I want a listing of every order number placed by the customer, and if you placed 10 orders this year, my report will have your customer information listed 10 separate times. Anyway, so crow's foot. Okay, the other style of ER diagram we're going to use, I'm not sure why that line keeps popping up like that. Okay, it's called Ch01. Okay, based on the last name of the gentleman who invented it. Ch01's database notation. You can Google crow's foot and Ch01's and get a little more information, but we're going to also talk about them moving forward. Okay, so these rectangles are the entities. The entities relate to the tables. So I have an entity type called customer. I have an entity type called order. And I've got an entity type called product. The lines here, and the lines can be either vertical or horizontal, or they can run in a diagonal, right? There's no law that says they have to be parallel or perpendicular or anything like that. Okay, the lines that connect the entities, these are my relationship connectors. And I'll have some demos, some screenshots to show you later. In one of our labs, I'm going to have you take a look at the databases that get installed with the Murok textbook. Now, I have your virtual machines, and we'll cover that in a separate lecture, already pre-configured, ready to go. The databases have already been installed. They're ready for you to use. SQL Developer, which is the application we're going to use, is going to give you output that looks something like this. I've run a query against some orders. Now, take a look at these dates, right? Okay, so these are the newest versions of the slides. Does it look like the data in this result set is sorted in order by order ID, by order date, or customer ID? Well, it's pretty obvious, right, that it's sorted in order by order ID. Okay. Now, these are 4 separate queries that produce 4 different result sets. Now, this slide talks about primary and foreign keys, which we require to set up relationships properly. We'll talk about primary and foreign keys a lot throughout the course, just not yet. Okay, but let's suffice it to say, right, this is the Pine Valley Furniture database, by the way. I don't yet have that pre-installed on your virtual machines. Okay, I might ask you to do that. We'll see. What I want you to understand from this screenshot, and we'll get to the point where you're actually doing this. What's the name of the customer ID whose ID equals 1? I can see, just a very quick scan, customer ID 1 has placed 2 different orders, 1001 and 1010. Who are they? I have to be able to relate this entity to this entity. And I'm going to introduce you to a command called select and a clause called where. I want to select all orders from the order_t table where customer ID equals 1, and then I'm going to join this table to this table, because maybe in my result set I want another column out here that includes the customer name. Okay, so we'll have to set up a relationship with a primary key in this table, and we'll relate it to the foreign key in this table. Now, if that doesn't make any sense to you just yet, it's okay, right? We're going to get there. Okay. I'm not going to read these bullets to you. I am going to say that using databases offers a whole lot of advantages. There are some disadvantages too, though. SQL, Microsoft SQL and Oracle, the Enterprise editions, super expensive because now they charge you based on the number of cores in your server. Whether it's a physical server or a virtual server doesn't matter. Your licensing costs can be tens of to hundreds of thousands of dollars, depending on the complexity of your environment, the size of your servers, right, number of cores. Plus, you can't just hire some jerk off the street. You have to hire someone who specializes in SQL or Oracle, especially if you're running a medium to larger size company. Okay, sure, you can hire that jerk off the street, but they're not going to follow best practices. Things are going to go sideways pretty quickly. Okay, and something that during the conversation about either installing a new system, migrating to a better system, etc., we have to have a hopefully short and affirmative conversation about backing up. Your data has to be backed up, right? Okay, too many people don't put enough stock into this. I want you to go back and think about those people I talked to that work with databases in the 10 terabyte size range. Now imagine the server holding that data crashed. What do you mean you don't have a backup? Where's all that data? Well, it's gone. So, all right, I'm going to show you these slides because they come with a textbook. I'm not going to talk about them at all, because we're going to get there eventually anyway. Okay, so this is slide 15. All right, so what goes into a DBMS, a database management system? Well, all manner of things. We can have what's called a 2-tier or 3-tier system. Okay, the difference is, do I have application servers in the middle or not? So I've got my users here who might be querying my database looking for information. I might have system developers if I have my own in-house team of folks who are designing web-based front ends, so I can have dashboards for my users to look at. Okay, we'll see a couple of examples of that later on. I've got DBAs, or database administrators. All of these people touch the database management system. Okay, now this slide shows that the database itself is a separate thing from the actual disk repository. And technically that is true. In fact, I would go so far as to say this repository in this context might mean storage for other items related to the database that are not the database itself, such as my ER diagrams. I'm going to have documents where I'm defining my business rules. We'll talk about business rules later, where I'm defining my relationships one-to-one, one-to-many, or many-to-many, etc. Okay, so this repository might be a separate area on the disk where all of my things related to the database that are not the database are saved. We're not going to talk about the software development lifecycle. Some of you might be development majors. Okay, so I am going to say, sure, we can talk about Agile and Scrum and extreme programming. We can talk about, oh God, what's the word I'm looking for? Like waterfall, and I don't do a lot of project management. Okay, so I'm not going to be able to speak in extreme depth about a lot of these things. Okay, but more likely, I've seen this slide where these steps are listed in a circle because it is a continuous process, right? Now, I've worked with so many companies that, sure, right, theoretically, this 5-step plan is awesome, but we don't actually put into practice these 5 steps. Okay, this is slide 19. Okay, if you want to look at these, I will not be asking you any test questions related to SDLC. Okay. Slide 20, if you want more information. So, all right. Now, as it relates to databases, I do have to talk about schemas. Okay, schema is a set of rules. Okay, in this context, schema refers to the view that we, the developers or administrators, have. The users of our system are going to have one view. They might be able to run pre-written queries to see pre-formatted reports. The designers will have a different view of the entities, their attributes, relationships, and the database designer, he or she will have a totally different but complete view of all of the pieces, okay, of our database management system. Right? So the external schema, right here at the top center of the slide, talks about what the users see when they log in. The conceptual schema is what the designers work on. Okay, what kind of tables are we going to use? What are the field names going to be? What are the data types going to be? Okay, the internal schema, this is where the logical meets the physical. So the design we have on paper actually gets put into practice. Okay. If you want to become a project manager, that's okay. This is not the class for that. You'll need to, at some point, earn the PMP certification, the Project Management Professional. I know a few people who have gotten it, and okay, it's expensive, and it might be well worth it, okay, depending on what you want to do for a living. Okay, I don't want to talk to you about managing the project. What I want to talk to you about is us as entry-level DBAs. Okay, because that's what this class is geared towards. Now, I am showing you all the slides, even if I'm not talking about them. Please feel free to pause the video, right, if you want to read these. Of course, you can download the slide decks. Okay. Okay, just a very quick history lesson. Databases came to be in the late 1960s. Yeah, believe it or not. Right? I was born in 1967, so by the time you're watching this, I'm either still 55, I might be 56 years old. Okay. Databases have been around that long. Okay. Some newer items though, and right, I don't know how involved in technology you are. Big data has been a thing since 2002, I believe. Now, if you aren't involved in big data, it might surprise you to learn that it's two decades old. Okay, data warehousing started in like 1989. I graduated high school in 1985, right here. Okay, yeah, some of these things have been around a long time. Again, I'm not going to ask you any history questions, okay? So we're going to skip past this. Yeah, we'll skip past this as well. Hierarchical versus network database models. What I'm going to ask you to understand, at least at the surface level. Let's go back one slide. I have not done a lot of database design, right? I am a server administrator. I've done database administration, but data modeling, data engineering, that's outside the scope of what I do. Normally, I have people who specialize in that stuff. They do all of this work. Where I get pulled in is generally this piece. The engineers have said we're going to need 2 servers set up on the network. They're each going to contain a copy of the database. We're going to mirror those databases in case one fails or in case we need to do maintenance like a Windows update on one server. The database continues to function. The engineers will also say to me, we need a web server that sits here in the middle because that's how our users are going to connect. Our users who don't know anything about networks, don't know anything about databases, may still be tasked with running quarterly tax reports, right? If you work in the payroll department. Well, what the heck? Are we going to teach them how to log into the database and pull the data they need? No, most likely I'll build the database servers. I'll build the web server. The database engineers will then install the DBMS, whether it's Oracle or SQL. They will set up the mirroring. Once I, with their assistance, actually roll out the database itself, the data has to get populated into that empty database. Again, that's generally not my job. I'm the server guy, not the database guy. Okay, so this process of getting data into the hands of the people who need it requires the combined efforts of a whole lot of people. Okay. Now, I have a separate Word document where I'm going to show you how one of these gets built. Now, those of you who have taken programming classes before, you're probably already familiar with OOP, right? Object-oriented programming. We're not going to get very deep into the weeds as it relates to OOP, but we're going to have to take a look at a relationship diagram and understand what the end results are supposed to be. My expectation for this class is not that you can build one of these from scratch, but that I can show you one and say, can you follow the logic of what I'm doing here? Now, as it relates to databases, instead of classes, right, I'm going to have an entity name here, like student or customer or employee. I'll have all the attributes listed here, right? So if this is the student entity type, what are some of the data points that Ch01 keeps on you? Well, one of your attributes might be your L number, right? When you filled out the application to become an Ch01 student, did they want your address, right? So your address is going to be one of your attributes. Again, my apologies for the penmanship. Okay, I may not ask you to design one of these from scratch, but I might show you a completed diagram called student, and there will be some attributes that I think Ch01 may track about you and ask if you can follow that logic. Okay. So let's not concern ourselves with this. I'm happy to answer questions about big data or data warehousing if you have questions. But again, those things are so far beyond the scope of this class. Okay. We, in this class, we're going to take a look at two things. We're going to look at Microsoft Access, and we're going to take a look at a stripped down version of Oracle's SQL Server. Oracle SQL is an enterprise database management system. We're using the personal edition. The databases we're working on will be in the 1 to 10 megabyte range, because there's no way are we going to be touching anything even remotely this large. For those of you who aren't comp sci majors, 1 petabyte is 1,000 terabytes. Okay, so, and this is a graphical representation of something I said a little earlier, where we have the client tier where we've got our users running reports, we've got our designers looking at the schemas, we've got our DBAs who are responsible for backing up the data, making sure that the servers are available. Generally speaking, and this is called a 3-tier system, generally speaking, we don't let our users touch the database directly. They have to go through some third party, in this case, an application or web tier. There will be things called APIs, Application Programming Interfaces, I believe the acronym stands for, that connect the web tier to the database tier. And generally, all our users work right here. Okay. And let's skip past that. This is a graphical screenshot of Power BI. Now, you can go to Tableau software. The link, this is slide 35. You can go to this link and you'll see this in color. This is what a Power BI dashboard looks like. Look at this data. Where do you think this data comes from? This data is populated, this chart, this graphic, populated in this dashboard because underneath the covers here, some design engineer has written queries to go back the last 3 months and pull how many orders, how much sales, right? And we're going to group those things by department. Now, we're not going to talk about how to design this, but we will talk about how did this data, right? How do we write a query to actually get this data displayed? We're going to do this, okay? This is pretty much where our class will end. The data exists. It's in this huge bucket, this huge repository. We have to go through that bucket and pull out just what we need. Okay, Pine Valley Furniture, maybe we'll talk about that later, maybe we won't. And that's the end of the deck. That's the end of MDM Chapter 1. So I'll end this video here, and I will talk to you all in the next one.